Hi everyone, so today we're doing Unit 2, Lesson 2. It's the properties of equality and congruence and the vertical angle theorem. So to start, we're going to list the properties. It says in geometry you accept postulates and properties as true. You can use deductive reasoning to prove other statements. Some of the properties that you accept as true are properties of equality from algebra. They are listed below in terms of any numbers A, B, and C. So here's the list, so you should copy down the list. We have the addition property of equality. If A equals B, then A plus C equals B plus C. You have the subtraction property of equality. If A equals B, then A minus C equals B minus C. Multiplication property of equality. If A equals B, then A times C equals B times C. And the division property of equality, if A equals B and C is not equal to 0, then A over C equals B over C. Then you have your reflexive property of equality, which is just A equals A. The symmetric property of equality, if A equals B, then B equals A. And then you have the transitive property of equality, if A equals B, and B equals C, then A equals C. And we're going to start using these. As we use them, you'll become more familiar with them. But for right now, just copy them down. Then below it says you can also assume that other properties from algebra are true, such as the ones below, which you should remember these. The substitution property. If A equals B, then B can replace A in any expression. And then the distributive property, A times B plus C equals AB plus AC. You would distribute that over distributive property. Going to the next page. It says the reflexive, symmetric, and transitive properties of equality have corresponding properties of congruence. So the properties of congruence, we have the reflexive property of congruence. Segment AB is congruent to segment AB, or angle X is congruent to angle X. Then you have the symmetric property of congruence. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. And then you have the transitive property of congruence. If segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. So let's try the examples and let's try to use some of these so you can get familiar with them. For example 1, it says name the property of equality or congruence that justifies each statement. So we have A, it says angle K is congruent to angle K. So because you have the congruence symbol here, we know we're going to use a property of congruence. So we can look in the chart right above, and angle K is congruent to itself. So we're going to use the reflexive property of congruence. B, if 2x minus 8 equals 10, then 2x equals 18. So right here, we have equal signs, so we're going to use properties of equality. So what we did to go from here to here is we added 8 to both sides, so it's going to be the addition property of equality. C, if segment RS is congruent to segment TW and segment TW is congruent to segment PQ, then segment RS is congruent to segment PQ. So we have the congruence symbol, so we know we're using a property of congruence, which means it has to be one of these at the top. And we have 3 terms here. We have 1, 2, 3. So we're going to use the transitive property of congruence, because if you look up here, that's what it says. If segment AB is congruent to segment CD, and CD is congruent to EF, then segment AB is congruent to segment EF. So C is the transitive property of congruence. And the last one, D. It says if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. So we have equal signs. We know we're using a property of equality. So it's going to be the symmetric property of equality. Example 2. It says solve for x and justify each step. So here we have segment NM plus segment MO is going to equal the whole segment NO. So we have NM plus MO equals NO. And that, from the previous lessons, we know is the segment addition postulate. Now we're going to substitute in what NM equals. So NM is 2x. So 2x plus MO is 3x minus 9. And that's going to equal the whole thing, 4x minus 4. So that we substituted the values in. So that's the substitution property. Now, right here we have 2x plus 3x minus 9 on this side of the equation. So we're going to combine like terms here. So that's 5x minus 9 equals 4x minus 4. So that would be called simplifying. Or combining. Combining like terms. So then from that, you're gonna subtract 4x, you get x minus 9 equals negative 4. And to get there, we did the subtraction. Property of equality. So you can, instead of writing property of equality every single time, you can just write POE. That's the abbreviation for it, property of equality. And then down here, we're going to add 9 to both sides. So you get x equals 5. And to do that, we added to both sides. So that's the addition property of equality. So for every step you did, there was a reason, a property why. Example 3. Solve for x and justify each step. So from the previous lessons, we know that the measure of angle ABD plus the measure of angle DBC is going to equal the measure of angle ABC. And that is, I didn't leave myself a lot of room here, but that we know is the angle addition postulate. then we're going to put in the values. We're going to substitute in the values. So the measure of angle ABD, it tells us is 3x plus 5, 3x plus 5, plus the measure of angle DBC is 6x minus 16 equals, and it tells us right down here, the measure of angle ABC equals EX. So we're going to put EX here. And so we substituted in the values, so that's the substitution property. And it's just substitution property. You don't need property of equality or anything. Just substitution property. So then we're going to simplify and combine our like terms, because again, on this side of the equation, we have 3x plus 5 plus 6x minus 16. So that's going to turn into 9x minus 11 equals 8x. And again, that was simplifying. Or combining like terms, and then from that point, we're going to subtract the 8x on both sides. So we're going to get x minus 11 equals 0, and that was the subtraction POE. And then we have to add 11 to both sides, and you get x equals 11. And we added to both sides, so that's addition POE, property of equality. And now we go to the last page. So it says, recall that vertical angles are two angles whose sides are opposite rays. So the vertical angle theorem, it says all vertical angles are congruent. So if you look at the picture here, it's an angle 1 and angle 2 are vertical angles. Angle 1 and angle 2. So angle 1 is congruent to angle 2. So that means angle 1 and angle 2 have the same measure. And then if you look also, angle 3 and angle 4 are vertical angles. So angle 3 is congruent to angle 4. So they have the same measure. So vertical angles are congruent. Last example. Example 4. It says find x, y, the measure of angle HML, the measure of angle JMK, the measure of angle HMJ, and the measure of angle LMK. So given the vertical angle theorem, we know that angle HMJ and angle LMK are vertical angles, so that means they're congruent, which means they have the same measure. So these are equal to each other. So we're going to set that equal. So 30x minus 10 equals 20x plus 30. So then we're going to subtract 20x, get 10x minus 10 equals 30. And add 10 to both sides. 10x equals 40. Divide by 10, divide by 10. X equals 4. So now we need to get y. So we know that angle HML and angle JMK are vertical angles, which means they're congruent. So these should be equal to each other. So we're going to set them equal. 9y minus 20 equals 7y. So then we're going to subtract 7y. Oh, subtract. I said subtract. Subtract 7y. So we have 2y minus 20 equals 0. Add 20 to both sides. 2y equals 20 divided by 2 divided by 2. Y equals 10. So now that we have our x and our y, the rest is easy. So first it says find the measure of angle HML. So we're going to write the measure of angle HML equals, so you have HML, so that's this, is 9y minus 20. So the measure of angle HML equals 9, y equals 10 minus 20. So that's 90 minus 20. So the measure of angle HML equals 70 degrees. And always put a box around your answer so we know which one it is. That's your final answer. So then we need to find the measure of angle JMK. That equals 7y. Measure of angle JMK equals 7 times 10. So the measure of angle JMK equals 70 degrees. Now we should have known that already because they're vertical angles. So they should be, the measures should be equal. But it's good to do the math out. That way you can check your answer. But they should be equal to each other. So then we have the measure of angle HMJ. So HMJ, it's 30x minus 10. Measure of angle HMJ, 30 times 4 minus 10. So it's going to be HMJ equals 120 minus 10. Measure of angle HMJ equals 110 degrees. And then the last part, so it's LMK, so it should equal 110, but we'll do it out just to make sure. I didn't leave myself a lot of room here, but LMK equals 20x plus 30. So then we have equals 20 times 4 plus 30. So that's 80 plus 30. So the measure of angle LMK equals 110 degrees. So those are the same. So we know we got it right. And that's the end of lesson 2. Have a good day.